Okay, the last video multiplied fractions, so now let's divide fractions. You're going to see dividing fractions is almost as easy as multiplying. There's one extra step we need to do. If I want to take 2/3 and divide it by 7/15, we leave the first fraction alone, we change the divide to a times, and we take that second fraction and we flip it over. I call it the old flip-flop. Okay, it's technically called the reciprocal, but the old flip-flop sounds better. And now we multiply. Okay, now again we have the same kind of, consequences, if you will. If we actually multiply it together, we're going to get two bigger numbers that we must then break apart in order to reduce them. Okay, you can see here hidden inside my 15 is a 3. So I see that now, so I'm going to factor this and call it 10 times 3 is 30, 7 times 3 is 21, 10/7. Okay, I might not have seen that though. I might have had 30/21 and, maybe said, oh, 6 times 5 is 30, 7 times 3 is 21. Now nothing cancels yet, so I have to keep factoring. Okay, 3 times 2 is 6. 7 times 3, now finally I can cancel and then remultiply and get the 10/7. So you'll get there either way, but sometimes it's easier just to spot what's going to cancel right over here at the beginning of the problem and instead of physically multiplying. Okay, so that's really it. Division has this one extra step. Okay, again, if we have a whole number thrown in the mix, we got to remember fractions rule and slap a denominator of 1 under it. Now it's two fractions again. There's no whole numbers to worry about. Do the old flip-flop, and that becomes a 1/5. 3/20. Okay? Piece of cake. Mixed numbers. Okay, squeeze that onto this page. 4 3/4 divided by 1 1/2. Okay, turn them into impropers. There's really no shortcut. So that'd be 19/4 divided by 3/2, which is 19/4 times 2/3. Okay, and I can see some canceling there, can't you? I know there's a 2 hidden inside my 4. So I'm just going to leave that 19 times 2, and I'm going to call that 2 times 2 is 4 times 3, so I can get those 2's out of there. So it's really 19/6. Okay, turn it back into a mixed number. I should have given myself a little more room and didn't. Squeeze it in here. Pardon me. I know 6 will go into 19 3 times because that gives me an 18. I'll subtract and get a 1, right? So it'll be 3 1/6. All right? So that's dividing mixed numbers. What about adding and subtracting these fractions? Oh, baby. Adding and subtracting. There's a problem when we're adding and subtracting. Okay. Let's look at the pie chart again. Here I've got 1/4. Let me just visually do it the same, even make it more visually appealing. Here I've got 2/4, right? So if I want to put these together, you can see what I'm going to do. I'm going to take this piece and I'm going to stick it right there, right? So now that's an empty pie. So if I want to add these together, well, now my pie is going to look like this. I'm just consolidating my pieces, and I've got 3/4 pieces. This pie is empty. I just moved the piece over there. Well, where did that 3/4 come from? It came from adding the numerators together and keeping the denominator as is. Okay, but I have this requirement that the denominators have to match. Okay, it doesn't make any sense if they don't match. Okay, because the pieces won't be the same size. Okay, if I've got that pie and then I've got this pie. Okay, well this is 1/4 and this is 1/2. Okay, and I want to try to add them together. It doesn't make sense. the pieces aren't the same size, okay? One piece is much smaller than the other piece. How can I put those two pieces together and claim that I've got two pieces somehow? It doesn't make any sense. Okay, so in this case, when that happens, we must find what's called the common denominator. Okay? And what we are doing when we do that is we are reslicing the pie. What if I reslice that pie? Now it's not 1/2 anymore. Now it's 2 out of 4. Okay? Same value, but I'm just thinking about it differently. Instead of calling it half, I'm calling it 2 out of 4. So now my 1 out of 4 plus my 2 out of 4 is going to equal my 3 out of 4, just like up there. Okay, so I have to get that common denominator, otherwise I can't do it. Okay, so that's going to be our challenge, finding that common denominator. You know, and having a visual chart isn't always realistic. Okay, if I want to even add something like 1/2 plus 1/3, I mean, I'd have to draw a 2-piece pie and a 3-piece pie, and how do you make that work? We need to find a common multiple of 2 and of 3. Okay, and there's procedures to find it, but when the numbers aren't very big, the easiest way for me to find it, just grab that first denominator off to the side and start counting by 2. So 2, 4, 6, 8, 10, 12, 14. And now grab the 3 and do the same thing. 3, 6, 9, 12, 15, 18. The first time I hit a match, and you see I hit a match at the number 6. The first time I hit a match, that's my least common denominator, my smallest common denominator. You see I hit other matches, and if I kept going I would hit matches all along. There's matches all the way down off the page here. Okay, but we always want to focus on the first match, which is my smallest common denominator. Okay, so what we need to do is we need to reslice this pie into a 6-piece pie and reslice that one into a 6-piece pie. And one of the beauties of fractions is that any number over itself, you know, some number 5 divided by 5, for example, is a 1, right? Any number divided by itself is a 1, with the exception of 0. You know, we can't take 0 divided by 0. That's what we call indeterminate or undefined. Okay, we're not even going to worry about it. Any other number, though. So I can ask myself, well, how do I turn a 2 into a 6? And I say, well, I'm going to multiply by 3. 3 times 2 is 6. And I'm going to do the same thing up top. So what I'm really doing is I'm multiplying by 3 over 3, which I know is just a 1. So I'm multiplying by 1, and that's not changing the value of my fraction. Over here, I'm going to multiply by 2 over 2. So what I really have is 3 over 6 plus 2 over 6. And now I've got that matching denominator. I'm going to call that 5 over 6. And that's how you do it. Okay, so adding and subtracting fractions, that's how we do it. We must find the common denominator, and then we simply add or subtract the numerators, and we keep that common denominator. Alright, let's do another one. How about... Let's do a subtraction this time. How about 3/4 minus 1/6? Okay? Step number 1, identify that common denominator. What is it? Well, if you don't know, let's start counting by 4s. 4, 8, 12, 16, 20, 24, 28, 6, 12, 18, 24, 30, 36. Where did we hit a match? We hit a match at 12, right? You see, we hit another match at 24, and if we kept going, we would hit more matches, okay? 12 is my smallest, okay? Worst case scenario, if you're struggling, worst case scenario, if you multiply the two denominators together, you're going to get a match. You see, we would get 24 if we did that. It's a match. It's not the smallest match, but it's a match. And if you're in a pinch, you can use 24 as your common denominator. You're just going to have to do more reducing at the end of the problem. So we like to use the smallest denominator so that the reducing at the end is at a minimum. Okay, so let's turn all these denominators into 12. How do I do it? Times 3 over 3 there, and times 2 over 2 there, right? That's going to give me 12 downstairs everywhere. So it's 9 over 12 minus 2 over 12. It's a subtraction problem now instead of an addition problem, but otherwise identical. I'm going to get a 7 over 12. Okay, just that easy. See why fractions rule, they're the best. Okay, let's try a mixed number, and I think we're done with these fractions. Sadly, well, they'll show up again, but done for the most part. 3 and 1/6 minus 1 and 11/12. Okay, we need the common denominator, but really, in my opinion, the easiest way to do this is to turn them just back to impropers. There's a way I can leave the whole number part alone and the fraction part alone and do it, but we might have to make a correction at the end. So I always just turn it back. So let's just do it. So 19 over 6 minus, what are we going to get here? 23 over 6, over 12. What's my common denominator here? Interesting. What is my common denominator here? It's 12, right? It's already there. It's already in part of my answer. You see that? So I really only need to manipulate this fraction and make that a 12, because that's already a 12. So I'm going to have 38 over 12 minus 23 over 12. Everybody cool with that? What's that going to give me? 15 over 12? Okay, so number 1, it's improper. So we should turn it into mixed number because the problem was mixed number, but we can also reduce. What can we do here? I can say 15 is 5 times 3, and 12 is 4 times 3. Goodbye 3, so it's 5 over 4. What can we do? We'll do the old longhand division. We'll say 4 goes into 5 one time with a remainder of 1. So we'll get 1 and 1/4. Okay? Alright, that is fractions, adding, subtracting, multiplying, dividing, fractions, and mixed numbers. And we'll get to other stuff. All right, we're going to talk decimals and percents in our next video. I'm going to call it quits for this one.